Okay, hello and welcome to the last unit on genetics. We're going to go through and try to attempt to take all the stuff that we've learned in the past couple of weeks and kind of apply them to family histories and traits and see if we can see any patterns that are passed on through the generations. So the thing that we use then is that we use something that is referred to as a pedigree. Okay, and what a pedigree is it's a family tree that traces the traits, okay, one or more traits that take place in a family. And so we're going to learn about how to read a pedigree. We're also going to go through and learn how to figure out how these traits that we're following in this family are inherited, whether they're inherited dominantly, whether they are inherited recessively, or if they are inherited through a sex-linked trait. Okay. All right, so the first thing that we need to do when going through and taking a look at these pedigrees is we have to understand what all these symbols mean. Okay, so we're going to go through that. Sometimes you're going to see, or not sometimes, you will always see that there are circles and squares. The squares represent males of the family, and the circles represent females. Okay, sometimes you go through and you are going to see that you will have circles that are filled in and squares that are filled in and are solid in color. Okay, so what do these mean? Well, the circle still represents that it is a female, okay, but when it is filled in, it means that this female is affected by the characteristic that we are looking at. Okay, if it is a square that's filled in, again, this is a male, and this male is then also affected by whatever trait that we are looking at. All right, so a few more symbols, and then we'll jump back up to this pedigree here. If you see a circle connected to a square that looks something like this, this represents that these two individuals are married. Okay. If I draw a line down from those two individuals, then I then can represent all of the children that these two people had. Okay. And if I take a look at this one, these two parents had a daughter first, then a son, and then a daughter. Okay. A couple other things that we'll see is that I might have a square that's represented here. Maybe he's affected by this characteristic. And if there is an X through them, this means that he is deceased. Okay. And we also might see that this daughter and her husband have a broken line, and this represents a divorce. Okay, all right. So that's kind of the basics of what these pedigrees mean. In order for us to come back up here and try to trace these characteristics, we need to make sure that we can very easily go through and identify specific individuals. And so we do that by giving them generation names. Our first generation right here, okay, is given a Roman numeral 1 for the first generation, and this is not to be confused with the F1 generations in your crosses. Those are kind of a different thing. These two parents gave rise to a daughter who is affected, a son who is not affected, a daughter who is affected, and a son who is not. And so these are their kids, and this is their offspring. And I apologize because my pen decides when to work and when not to work, and I haven't figured out how to control it yet. So there we go. There's the second generation. All of these brothers and sisters then were, well, most of them anyway, were married and had children, which gave rise to our third generation. Okay, and then we have down here on this row our Roman numeral 4 for our fourth generation, and that applies to everyone in this row. Okay. So now we're going to come up, and what we're going to do is we are going to number the individuals from left to right, okay, in the generation. So this is generation 1, person number 1, generation 1, person number 2. When I get down to generation 2, I'm going to start over. Here's 1, 2, 3, 4, 5, 6, and 7. And I'm going to continue numbering and starting over at each generation. Okay, 5. Okay, now that I have everything numbered here, now we can go ahead and we can start trying to figure out how exactly are these characteristics related. So when I like to go through here is I like to scan and search the different generations, and I like to look for two parents who do not have the characteristic but then give birth to individuals who do. So if I take a look at generation 2, individuals 3 and 4, both of them are open. They do not have this trait. And then they give birth to 2 children, and both are also not affected. So that doesn't really help me a whole lot. But if I look down here at people 9 and 10 in the 3rd generation, okay, what I do see is that 9 and 10, neither one of them have this characteristic, but they did give birth to an individual who did. All right, so now we have to think back to our Punnett squares and all of the work that we've been working through, and try and figure out what is the only possible combination of having 2 parents who do not have a characteristic and then end up with a person who does. Okay, and so that gives me an indication that this person right here, I was going to switch colors. Sorry, you guys, I'm new with this. So that this person right here has got to be homozygous recessive. Okay, so person number 4 then is homozygous recessive. So where do these genes come from? Well, this little a, if you remember, has to come from one parent. It has to come from this parent up here, which is number 10. The other allele, the other gene, has to come from the next parent over here, who then also needs to be a little a. Okay, but if parent number 9 was homozygous recessive, little a, they also would have it colored in. Now, because this individual is not homozygous recessive, because they are not colored in, that tells me then that if you are, quote, uncolored or normal, you are going to be dominant. Okay, and so everybody that has this colored in box has got to be homozygous recessive. Okay, so we can come back over here to my Punnett square as a practice, and we see big A, little a. We have a big A and a little a, and if we fill this all in, we can see here that I get my homozygous recessive combination. Okay, now I'm going to erase some of this stuff, I think. Oh, look at that. Pretty slick. Okay. All right, so we now know that if I am filled in, I am homozygous recessive. I can come up here to A at 2, and because she is also filled in, I know that she also is homozygous recessive, and I can fill all of those branches in. All right, now let's go back to our parents here. Okay, remember this girl here, or this little a, came from this parent, so that's a little a, and this little a came from over here. We stated that it is heterozygous because that's the only way that number 4 would get both copies, and the parents not have that trait. Okay, so we know that. All right, so what else do we know? Because we can work backwards through this. Okay, in order for this parent number 6 in generation 2, okay, to not have it, they have to be a big A. Okay, and their second letter could be a little a, or it could be a big A. Okay, we don't know. So we need to look at their offspring. Okay, if we come down and we trace this, okay, what do we see? We see an open circle. We know this is a big A and something. We see an open square, which is a big A and something. And we see another open square, which is big A and something. So it doesn't tell us a whole lot by just looking at this set of parents. Okay. All right. So can we come up here? Okay, remember this individual, this daughter, came from these 2 people. Okay, so this little a here had to come from one parent. We're going to put it here. This little a had to come from the other parent. Okay, and very similar as to what we did down here with generation 4, person number 4 is that we know that this individual is homozygous recessive, okay, and they're colored in, and they came from 2 parents who were not affected by this characteristic. And so their genotype must be big A, little a. Okay. All right, so let's go ahead and take a look at the different characteristic. Oh, let me back up here. Sorry. All right, so what this tells us is that this trait, or this pedigree right here, has a trait that we are following, and everybody in it is affected by a recessive trait. Okay, so now we're going to move down here to this second pedigree that I have. All right, and again, we're going to see the same thing. We've got generation 1, we have generation 2, and we have generation 3. Okay, again, I like to scan through, and I like to find, where am I looking? Sorry, parents here, okay, who do not have this disease or have this characteristic, but then, yes, do give rise to a characteristic that does have it. Okay, sorry about that, I paused. This was not what I wanted to show you, but we'll go through it anyway. So I take a look here and I see that these 2 parents here do not have the characteristic, but they have an offspring that does, an actual son. And so again, the only way to get individuals that are affected by a characteristic and having parents that do not is to be homozygous recessive at this end. We actually can go back through 3 and 4, and let's just flip it around and pretend that we want the open people to be homozygous recessive. That means that everyone that is open is homozygous recessive. So that would be 2 and 6 and 12 and 11 and 10. Okay, as well as 3 and 4. And so if that is the case, and I come and I fill in my pedigree or my Punnett square box, I see that if I have 2 individuals who are homozygous recessive, the only thing they will get is more homozygous recessive. So there would be absolutely no way for these 2 parents to give birth to somebody who is different than them. Okay, so we then do know that it has to be basically kind of the opposite, that the open circles are going to be, oh, that didn't work, sorry, that the open circles, I don't know what happened, nope, pause. Okay, well, hopefully you're getting a kick out of my mistakes, but I'm learning how to use this. So we're almost done. So what we're going to do, so this is little a, and we are going to move on to this last one, maybe. Okay, I guess we're not going to move screens. All right, so I'm going to have you guys go through, and you are going to take a look at a couple of the practice problems that I have with pedigrees. And I guess if you have any questions, I will be around this afternoon, and you guys can come in and take a ask some questions if you need to. But you should be able to get pretty good on this. A couple things I want you to remember is that if you don't know the whole genotype, you can always do big A and then a dash. But if you do know, and there is a real answer, you do need to pick if there's a big A and a little a, or if it's big A and big A. Okay? But you should very clearly be able to pick out most of the time which genotype it is. If it is really unclear, because it really could be either one, then we represent it as a big A and then something else. And again, pick whatever letter you want, just be consistent. Okay? All right, have fun with pedigrees, and I will see you later. Thank you.